Imagine piloting a starship, a vessel of incredible technology, venturing into the unknown. Feel the hum of the engines, the subtle vibrations as you prepare to embark on a journey unlike any other. Your destination, the silent blackness of deep space, a realm where stars are scattered like diamonds on an infinite velvet cloth. It's a place of profound solitude, where the only sound is the gentle whir of your life support systems. The stars are brilliant, each one a distant sun, burning with unimaginable power. They paint the void with vibrant colors, a breathtaking spectacle that stretches out in every direction. But ahead, something is different. A patch of sky is missing, a void where stars should be, an anomaly that defies the beauty around it. It's a perfect circle of nothingness, a stark contrast to the luminous tapestry of the cosmos. This is no ordinary emptiness, it's a presence, a force, a mystery waiting to be unraveled. Starlight bends and warps around this void, distorted by an unseen power. The light's journey is no longer a straight path, but a curved dance around an invisible giant. It swirls like water circling a drain, a cosmic whirlpool of light and energy. Matter is pulled inexorably towards the center, accelerating to incredible speeds. You've arrived at a black hole, a place where gravity reigns supreme, a cosmic enigma that challenges our understanding of the universe. Here, the laws of physics are pushed to their limits, stretched and twisted beyond recognition. It's a realm where the familiar rules no longer apply, where the impossible becomes reality. This gravitational monster is so powerful, so immense that it warps the very fabric of space-time around it. Its pull is inescapable, so strong that not even light, the fastest thing in the universe, can escape its grasp once it gets too close. Once it crosses a certain boundary, known as the event horizon, there's no turning back. It's a one-way trip into the unknown. The darkness is a prison for light, a cosmic jail cell where photons are condemned to an eternity of darkness. Every photon that strays too close is lost forever, swallowed by the abyss, adding to the black hole's insatiable hunger. Your ship's sensors scream warnings, flashing red alerts, urging you to retreat from this perilous place. They're detecting a gravitational pull beyond comprehension, a force that threatens to tear your ship apart. The very fabric of space-time is distorted here, twisted and warped into bizarre shapes. It's a visual representation of the immense power at play. To fall in would be to vanish from our universe, to be erased from existence as we know it. You would be stretched and torn apart by unimaginable tidal forces, a process scientists call spaghettification. Black holes are not just science fiction, they're not figments of imagination confined to the pages of novels or the screens of movies. They're real, tangible objects, confirmed by scientific observation and groundbreaking imagery. They represent the dramatic endpoints for massive stars, the final act in a cosmic drama of birth, life, and death. They're also the engines at the heart of galaxies, the supermassive behemoths that shape the structure and evolution of these cosmic islands. By studying them, by peering into their mysterious depths, we peer into the very nature of reality. Pushing the boundaries of our knowledge and understanding of the universe, we can ask the biggest questions, the fundamental inquiries that have plagued humanity for centuries. Where did we come from? What were the initial conditions that led to the universe we observe today? And what is the ultimate fate of the cosmos? Will it expand forever, or will it eventually collapse in on itself? These are the questions that drive us to explore the edge of everything. Welcome to the Space Vault, your portal to the universe's greatest mysteries. Here we don't just look at the stars, we seek to understand them. Our mission: unlock the secrets of the cosmos, from the tiniest particles to the largest structures. Today, we open the vault on black holes, nature's ultimate extremes, where matter is crushed and gravity rules. Once just a theory, we now know black holes are real, shaping galaxies and challenging our understanding of space and time. At Space Vault, we make these wonders accessible to everyone, using simple analogies and stunning visuals. Get ready to have your mind expanded as we journey into the heart of darkness. The vault is open, the mysteries of the black hole await. What is a black hole? It's a question that has captivated scientists and stargazers alike for decades. These enigmatic objects challenge our understanding of the universe and push the boundaries of physics. It's an object with gravity so strong that nothing, not even light, can escape its grasp once it crosses a certain boundary. This boundary is known as the event horizon, the point of no return. Imagine a star many times more massive than our sun, a colossal giant burning brightly in the vast expanse of space. These stars live fast and die young, setting the stage for the birth of a black hole. Now, imagine that star's entire mass crushed into a space just a few kilometers across. The density becomes unimaginable, the gravitational forces overwhelming. The result, a cosmic heavyweight, a region of space-time where gravity reigns supreme. It's a place where the laws of physics as we know them break down. It's a trap from which nothing escapes once it gets too close. A one-way ticket to oblivion. Anything that ventures too near is inexorably pulled in, never to be seen again. Most black holes begin with the death of a giant star, a dramatic end to a stellar life. These stars exhaust their fuel and can no longer support themselves against their own gravity. When fusion stops, gravity wins, relentlessly crushing the star's core. The immense pressure forces protons and electrons to combine, forming neutrons, and the core collapses in a fraction of a second, triggering one of the most powerful events in the universe. This triggers a supernova, a cataclysmic explosion that briefly outshines entire galaxies, blasting outer layers away, scattering heavy elements into the cosmos, enriching the interstellar medium, while the core collapses into a singularity, if the star is massive enough. An infinitely small, dense point. All the star's mass is compressed into a volume of zero, a concept that defies our everyday intuition. To grasp this, imagine squeezing Earth into a marble. The sheer density is almost impossible to comprehend. Its gravity would become inescapable, warping the fabric of space-time around it. Black holes come in different sizes, from relatively small stellar mass black holes to the truly gargantuan supermassive black holes. Stellar mass black holes from dying stars, typically a few times the mass of our sun. And supermassive black holes, millions or billions of times the sun's mass, lurking at the heart of most galaxies. At the centers of galaxies, exerting a powerful influence on their surroundings, we're still unraveling how these giants formed, a puzzle that continues to challenge astronomers. Did they start small and grow, gradually accumulating mass over billions of years? Or collapse from massive gas clouds? Perhaps these clouds directly imploded, bypassing the need for a stellar seed. Perhaps they grew by swallowing stars, ripping them apart with their immense tidal forces. Gas, vast streams of interstellar material spiraling into their hungry maws, and even other black holes merging in spectacular cosmic collisions that send ripples through space-time. Or maybe they were born huge in the early universe, springing into existence shortly after the Big Bang. Either way, they're among the most mysterious objects in existence, continuing to baffle and intrigue scientists. Black holes challenge everything we know about matter, gravity, and the universe itself, forcing us to reconsider our fundamental understanding of physics. They are a testament to the extreme and often bizarre nature of the cosmos. Every black hole, regardless of its size or origin, possesses a boundary. This boundary isn't a physical barrier in the traditional sense, but rather a critical threshold in space-time. It's known as the event horizon, the point of no return, a cosmic precipice. Once crossed, there's no going back, no escape. It's not a surface you could touch or bump into, but a threshold, a one-way membrane in the fabric of space-time itself. Outside the event horizon, escape is still possible, though increasingly difficult the closer you get. You can still fire your rockets and pull away. But inside, beyond that invisible boundary, nothing, not even light, can escape the black hole's relentless grip. Near the event horizon, the effects of gravity become so extreme that time itself slows dramatically. Imagine hovering just outside the event horizon. Hours for you could translate into centuries, even millennia, on Earth, a consequence of the extreme time dilation. If you were unfortunate enough to fall in, the tidal forces, the difference in gravitational pull from one part of your body to another, would begin to stretch you. This process is often referred to as spaghettification, a rather descriptive term for what happens when gravity exerts its ultimate influence. You'd be pulled apart, atom by atom, stretched into an incredibly long, thin strand of matter. For smaller, stellar mass black holes, this stretching is an instant and fatal process. There's no gradual transition, just immediate disintegration. However, supermassive black holes, the behemoths that reside at the centers of galaxies, have gentler tidal forces at their event horizons. Because of their immense size, you might actually cross the event horizon without even noticing the change. But don't be fooled, the stretching will inevitably begin, just further inside the black hole. Once inside, no message, no signal, no information of any kind can ever escape to the outside universe. Your fate is irrevocably sealed, lost to the infinite depths of the black hole. The event horizon stands as the universe's ultimate one-way door, a boundary beyond which our current understanding of physics begins to break down. Time, space, and matter itself are warped and distorted beyond anything we can readily comprehend. Black holes serve as a constant reminder of just how strange, how extreme, and how utterly fascinating the universe can truly be. They represent the ultimate test of our understanding of physics, pushing the boundaries of what we know and challenging us to explore the unknown. For decades, black holes were theoretical, seen only through their effects on nearby stars and gas. But in 2019, the Event Horizon Telescope, a network of radio telescopes across the globe, captured the first direct image of a black hole shadow in galaxy M87. We saw a dark center, the event horizon, surrounded by a glowing ring of superheated gas spiraling toward oblivion. This image confirmed Einstein's predictions and proved black holes are real, active parts of the universe. M87's black hole fires jets of particles thousands of light-years into space. Closer to home, Sagittarius A* anchors our own galaxy. Its image, released in 2022, showed a similar glowing ring. Scientists tracked stars whipping around it, providing powerful evidence of its existence. These images transformed black holes from theory to reality. We can now see the unseeable. Ready for some mind-bending black hole facts? If our sun became a black hole, its event horizon would be just 3 kilometers wide. Earth would keep orbiting as usual. Black holes aren't cosmic vacuum cleaners. You have to get close to fall in. Most black holes spin, dragging space-time with them and creating a region called the ergosphere, where nothing can stand still. Some black holes power quasars, blazing beacons that outshine entire galaxies. Stephen Hawking discovered black holes emit Hawking radiation, meaning they can slowly evaporate over unimaginable timescales. Black holes aren't eternal. Eventually they may disappear, releasing everything they've swallowed, though in a scrambled form. They're among the brightest and strangest objects in the universe. Black holes are cosmic paradoxes, destroyers and creators all at once. Black holes aren't just destructive, they're architects of the cosmos. Supermassive black holes anchor galaxies, shaping their structure and evolution. The mass of a galaxy's central bulge is linked to its black hole, suggesting they grow together. When black holes feed, they unleash energy that can regulate star formation, shaping the galaxy's fate. Black holes also recycle matter. Mergers send gravitational waves across the universe, forging heavy elements like gold and platinum. These elements are essential for planets and life itself. The violent lives and deaths of stars, and the black holes they leave, are part of our own origin story. Black holes connect us to the universe's grand design. Despite our progress, black holes remain deeply mysterious. What happens at the singularity? Our physics breaks down there. We need a new theory of quantum gravity. How did supermassive black holes grow so big, so fast? Did they form from massive gas clouds or merge from smaller seeds? Future missions like the Laser Interferometer Space Antenna, LISA, will detect black hole mergers across the universe, revealing new secrets. We hope to test wild ideas. Do wormholes exist? Can black holes be fully described by just mass, spin, and charge? Every new discovery brings us closer to understanding the cosmos. The journey is far from over. We've explored black holes from their birth to their cosmic influence. They're not just vacuum cleaners, they're engines of galaxies and keepers of deep secrets. Once a bizarre theory, black holes are now a proven reality, thanks to global collaboration and scientific curiosity. Science lets us reach across the void and understand the incomprehensible. The questions we ask about black holes are the latest in humanity's long quest to understand the universe. The cosmos is a magnificent story, and we're lucky to read its chapters. Keep looking up, keep asking questions. The next great discovery could be yours. The adventure continues, and every one of us has a role to play. Just pause, gaze at the stars, and wonder.